Hi, Assalamualaikum. My name is Aimi Amirul bin Mazlan. My matrix number is 14DEM21F1062. Today, me and my team will present about application of differentiation and about topic maximum, minimum and inflection point. So, for a function y equal to f in bracket x, a stationary point is a point on the function graph where the gradient of the function is 0. If the gradient of the function changes sign at the stationary point, then it is called a turning point, which can be local maximum or local minimum. As you can see, in the picture, in the graph, we show the maximum minimum point of the graph.
Hi, Assalamualaikum. My name is Raja Azri bin Raja Ismail. My matric number is 14DEM21F1018. I will go through the explanation. If the gradient of the function does not change sign at the stationary point, then it is a point of horizontal inflection. The derivative of the function y equal to fx gives us the gradient of any points, so that if we know the derivative dy over dx, then we can locate the stationary point of the function y equal to fx without even drawing graph. Also, by evaluating dy over dx just before and just after each stationary point, we can find out if it is a local maximum, local minimum, or point of horizontal inflection. The second derivative can be used as an easier way of determine the nature of stationary point, whether they are maximum point, minimum point, or point of inflection. A stationary point on a curve occur when dy over dx equals 0. Once you have established where there is stationary point, the type of stationary point, maximum, minimum, or point of inflection can be determined using the second derivative. So we look at the table below. Differentiation. If d power of 2y over ds more than 0, it is positive and stationary point is minimum point. If d power of 2y over ds less than 0, it is negative and stationary point is maximum point. If d power of 2y over ds equal to 0, so it is point of inflection. Okay, that's it from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syahid Hazid bin Sarmat and my matric number is 14DEM21F1010. Now, I will answer the question that has given. Firstly, we must differentiate the function. dy per dx equal to 3x square minus 12x. After that, we must factor the answer that we have. We can get the x equal of 0 and x equal of 4. After that, we must put that x into the function. Substitution that x one by one. For first y, we can get the answer is negative 20, and the second y is 12. So we can get two coordinate at the same time. The coordinate is 0, 12 and 4, negative 20. After we get the coordinate, we must differentiate it another time. For the formula is d2y over dx2. For the first differentiate, we get the answer is negative 12 lower than 0, and the second differentiate is 12 over the 0. Now we can conclude that 0, 12 is the max point and 4, negative 20 is the minimum point. After we get the minimum and maximum point, we must draw a graph. The graph is like the image that I put beside.
Assalamualaikum warahmatullahi wabarakatuh. My name is Suman Habib Ahmad Daniel. My number matrix is 14DEM 21F1066. So the question is, F in bracket X equal X square in bracket 4 minus 2X equal 4X square minus 2X power of 3. So the how to solve it is dy per dx equal X. Then dy per dx equal 8x equal 8x minus 6x square. So when you get negative 6x square plus 8x equal to 0, then you use calculator, then you got x1 equal to 0 and then x2 equal 4 over 3. So we do x1 first. We need to replace x1 in that itu x equal to 0, so y equal 4 in bracket 0 square minus 2 in bracket 0 power of 3. Then you use calculator, you get equal to 0. So x2 equal to power 4 over 3, then equal 4 in bracket 4 over 3 square minus 2 in bracket 4 over 3 power of 3. So you get 64 over 27. So the stationary point at 0 0 and 4 over 3 0. So d square y per dx square equal 8 minus 12x. So 0, 0, d square y per dx square equal 8 minus 12 in bracket 0. So you got the answer is 8. So 8 more than 0, so it's positive. So when positive, our graph will be like a smile like this. So next, 4 over 3, 64 over 27. So d square y per dx square equal 8 minus 12 in bracket 4 over 3. So you got the answer negative 8. So when negative 8, it's smaller than 0, so it must be negative. Your graph will be like this, like a set, not a smile, like a set face. So if 0 0 minimum and 4 over 3, 64 over 27, it will be maximum. So your graph will be like this, smile and then set face like this.